Hi, everyone. We are going to talk about function transformations today. The first thing that we need to talk about is a parent function. I've referenced this in my linear function video, but a parent function is the most basic form of a function. It has no adjustments to it. It's just the very basic y equals something x. For instance, y equals square root of x. Y equals x squared. There is no scaling factor, no shift, no reflection. It's just the most basic form. Here are a few functions that are parent functions. We have y equals x, that's a linear function. Y equals x squared, that is a quadratic function. Y equals the square root of x, that's a square root function. Y equals e to the x is an exponential function, and y equals sine of x is a trigonometric function. Transformations is where we obtain a new function from an existing function. Essentially, we manipulate the parent function in some way. For instance, you could take a linear function that goes through the y-intercept of 0 and move it up. You could shift it down. You could shift it right. You could shift it left. You could reflect it. You could stretch it. You could compress it. Quite a few different options. Common ways to transform, shift, scale, and reflect. We do these using certain operations. Shifting happens inside and outside of the function, depending on whether you're adjusting x or y. Same thing with scaling and same thing with reflecting. Shifting is adjusting your graph left or right, up or down. So it can be done horizontally. It can also be done vertically. Scaling, meaning you're making it larger or not, so you can stretch or compress vertically and horizontally. Reflections can also happen horizontally or vertically, either across the x-axis or across the y-axis. The way in which we shift is we take a parent function and we manipulate it. I'm going to call the parent function y equals f of x. And that is because the parent function is some function of x. It could be x being squared. It could be x being square rooted, some function. But we just have this function here. How do we shift it horizontally? How do we shift it vertically? So we are manipulating the parent function. In order to shift left or right, that happens inside the parent function, parentheses with x, and shifting vertically happens outside. K is just some arbitrary number, but whether K is positive or negative tells me whether I need to shift up or down. Same thing with H. Whether H is positive or negative tells me whether I need to shift left or right. If K is positive, we're shifting up that many units. If K is negative, we're shifting down that many units. But notice that we use absolute value for K because if you shifted down -3, that's actually up 3. So you would shift down 3. For instance, this might look like y equals f of x plus 3 or y equals f of x minus 2. The first one takes the function up 3. The second one takes the function down 2. When we're talking about a horizontal shift, this is something that is done inside of the function, but it's not going to be plus, it's actually going to be a minus. And so we would write y equals f of x minus h is the variable that we use here. And so notice that the sign is different. And so because of that sign, the way in which we shift left or right actually seems opposite of what you would see. So what you see here is if h is greater than 0, h is positive inside the function, you're going to shift right h units. And if h is negative, you're going to shift left h units, absolute value, because you're not taking that negative sign, you're just moving that many to the left. Let me write it for you in function form. What if I said y equals f of x minus 3 and y equals f of x plus 4? Minus 3, when you just look at that on its own, it looks like you should be going to the left because this is horizontal. Since it's inside, it should be left 3. But that's not actually true because we originally start with minus h in general. So the h is actually positive, and you're going to the right 3. Whereas x plus 4 looks like you would be going plus 4 on x when you're actually going minus 4 on x. But I like to say that h is a liar because when you just look at the function as is, it seems backwards, but you have to remember the original transformation is f of x minus h. So this one would be right 3, and then the second one would be left 4. If we're going to scale vertically versus horizontally, when you're scaling vertically, you can both stretch and compress depending on whether you're multiplying by a whole number or a fraction, or a number greater than 1 or not. And same thing with horizontally. You can stretch or compress horizontally. In this case, we are going to assume that our c that we're using, the variable that we're using like h or k, is greater than 1, meaning it's positive, because when something is negative, it's actually a reflection. So this is going to be for c greater than 1. And we're going to vertically stretch outside the function, and horizontally is going to be done inside the function, just like shifting. So let's say I have y equals c times f of x, and y equals 1 over c times f of x. That's outside the function. That happens with a vertical scale. If I put the c inside the function, that's going to become a horizontal scale. That will be y equals f of cx, or y equals f of 1 over cx. Okay. If I'm multiplying by a number that is larger than 1, that's positive, say for instance 2, I'm going to stretch the graph vertically. It's going to pull it up. When you have 1 over c, so for instance, like 1 over 2 on the outside, that's going to compress your graph vertically, but still by a factor of c. Horizontally, when we do inside the function, y equals f of cx, instead of c being a stretch, c is going to be a compress on the inside. So if y equals f of cx, we're going to compress the graph horizontally by a factor of c. And then when you have 1 over c on the inside, that's going to stretch the graph horizontally by a factor of c. Stretch, compress, shift, left, right. What does this mean? I'll show you some examples in a minute. Our final transformation that's common is reflections. Remember, I said that c was greater than 1. So in this case, c equals -1. So you have the negative function on the outside or negative function on the inside. A negative on the outside is going to reflect your graph across the x-axis. That's going to be vertical, up and down. Negative on the inside is going to be horizontal, left and right, over the y-axis. Y equals f of -x is going to reflect across the y-axis. For the first example, y equals the square root of x plus 1. This is a square root function. The parent function is square root of x, and so we have +1. How do I know whether it's inside or outside? A square root function on the inside is underneath the root. Because this is not underneath the root, this is outside the function. So if I'm adding outside the function, that is a shift vertically. That means that I'm taking the square root function up 1 vertically. So this would be a shift of f of x equals root x up 1. And remember, f of x and y are the same thing. So it's the shift of y equals root x, or the shift of the function f of x up 1. What if I said y equals the square root of x over 2 minus 3? That's all underneath the square root. So that's going to be something that's happening to the x value. I'm subtracting, and remember, add or subtract is either shifting up and down or left or right. I'm subtracting inside, which means I'm going to go left or right. And inside is a liar. So instead of going to the negative, I'm actually going to the positive 3. So this is shifting the square root of x 3 to the right. And then when I'm taking that inside, we're going to be stretching by a factor of 2. And in this case, it's stretching horizontally because it's inside. So the horizontal things happen inside, the vertical things happen outside. Let's do another example. What if I said y equals negative square root of x minus 2? The minus is happening on the outside. That means it's going to be something vertical, and I have a negative in the front of the function. That's a reflection. I have a vertical reflection and a vertical shift. It seems weird to think that a vertical reflection is across the x-axis, but when you flip over the x-axis, that happens up and down. Let's say I had some function where I take y equals negative 3 square root of 2x plus 5 minus 2. I have a lot of things happening here. I have things happening inside and I have things happening outside. Starting from the left, this minus sign is going to be a reflection. It's happening on the outside, so that's going to be a vertical reflection. The 3 is actually on the outside as well, and it's a number that's bigger than 1. And so that's going to stretch the graph vertically by a factor of 3. Moving inside, I have a number that is also greater than 1, but when it's on the inside, it's not a stretch, it's a compress. And it's a compression horizontally by a factor of 2. Plus 5 on the inside, h is a liar. Instead of going right horizontally, I'm going to go left. So I'm going to go left 5. And then finally, that minus 2 on the outside, that is a vertical shift down 2. We're going to head over to Desmos now to look at some of these transformations on a graph. Here in Desmos, we have a parabola set up. A standard parabola is y equals x squared. There's an intercept of 0 and a scaling factor of 1, meaning when I have 1, 1 squared is 1. When I have 2, 2 squared is 4. So it goes to the points 1, 1, and 2, 4. Those are some standard things about a parent function of a parabola. I have the function set up where I have c on the outside of the function. I have x, I have minus h is inside the function, and I have k. So I'm going to add our parent function here of y equals x squared. So you can see it's now the black is overlapping the blue. But let's say I add h. I'm going to make this a positive 1. So that would be like x minus 1. As I move that x minus 1, my graph shifts to the right. So even though my h is positive, and this would be x minus 1, I'm shifting right. So the further right I go happens when h is positive. Go back to when h is 0. And if I go to the negative, where the inside would become h plus something, I'm shifting to the left. So remember, h is a liar. So positive h's go right, negative h's go left, but my original function starts at 0. What if I added k on the outside? Adding goes up, subtracting goes down. So if I have a negative k value, my graph's going to go down. When I have c on the outside greater than 1, remember c is positive in this case, so c greater than 1, when I increase, I am stretching the graph vertically. Going back to 1, if I make this 1 over c, and I have, let's say, 1/2, so 1 over where c is 2. Notice that I'm now compressing. The larger that I get, the more that I compress that graph vertically. I'm going to now shift the c onto the inside. And let's say I multiply by a larger number. I am compressing horizontally. When I have 1 over c, I'm stretching it horizontally this way. Going back to a standard c, putting a negative c on the outside reflected the graph vertically over the x-axis. And when I put a negative c on the outside here, can't see it because a parabola is the same when you reflect it horizontally over the y-axis. Let's take a look at a different function. I have a parent function of y equals the square root of x. My standard function is in black. Square root goes off into the positive, and when I put a negative on the inside, it reflected the other way. Okay. Hope this visual was helpful for you. Thanks for watching and have a great day.